Hi, today we are going to be learning about chemical reactions, and we're going to do that by performing an experiment. Chemical reactions are when substances change into different substances. Today I have hydrogen peroxide, I have warm water, I have dish soap, and I have yeast. And I also have food coloring, but that's just for fun. And we are going to be making elephant toothpaste. I am going to start by taking the 3% hydrogen peroxide, and I'm going to pour about a half a cup, it doesn't need to be exact, into my bottle. I'm going to do a little bit more. This is coming out slower than I thought it would. All right, so we're going to put in hydrogen peroxide into the bottle. And then after that, I'm going to put a little bit of dish soap. And what's going to happen in the chemical reaction is this hydrogen peroxide, which is 2 hydrogen atoms bonded with 2 oxygen atoms, that's H2O2. That is going to have a chemical reaction and turn into water and oxygen gas. So now that I have my hydrogen peroxide in the bottle, I'm going to put a little bit of dish soap in here. And I'm just going to swirl that around. I'm not going to shake it to make it real bubbly. At this point, I'm just going to swirl it a little bit. Then I'm going to add the food coloring. And the food coloring is just for fun today. So I'm going to add some blue food coloring. That'll make the elephant toothpaste blue. I'm going to swirl all of that around. And then I'm going to take my dry yeast and I'm going to put it into the warm water. And yeast can be a little bit messy sometimes. It likes to stick to things like the glass. And I'm going to just give that a little bit of a stir with my spoon, and we're going to let this sit for about 30 seconds. So the yeast in this chemical reaction is going to act as a catalyst, and that's going to help speed up the chemical reaction. Okay, I'm going to put my funnel into the bottle, and I'm going to give the yeast just a couple more seconds, and then we're going to pour the yeast mixture in with the hydrogen peroxide, dish soap, and blue food coloring, and we're going to see what happens. The funnel will make this easier, so I'm pretty messy. This will keep it from getting all over the place. All right, I poured that in, and there is our elephant toothpaste. It's not as blue as I would have liked, but you can see that it's bubbling all over. Now, do you think that we could brush our teeth with this elephant toothpaste? The answer is no. Although it looks like toothpaste, it is really oxygen bubbles, because that hydrogen peroxide is changing into water and oxygen gas. And it is still going. And this Let's break down a little bit what happened in our experiment where we made elephant toothpaste. We took hydrogen peroxide, which is 2 hydrogen atoms bonded together with 2 oxygen atoms, and we added dish soap and we added yeast, and it turned into water, which is 2 hydrogen atoms bonded with 1 oxygen atom, and oxygen gas. And that oxygen gas is what we saw, the thousands of little bubbles that we saw was the oxygen gas. And so chemical reactions are when substances change. So in this case, hydrogen peroxide broke down into water and oxygen gas. So why did we add yeast? What was yeast's role in our experiment? Yeast is actually a living fungus. So it is alive, and it is so small that we would have to look with a microscope to see a single cell of yeast, but it is a fungus, and yeast produces something called catalase, and that catalase is a catalyst. And what a catalyst does is catalysts speed up chemical reactions. So that's the role that yeast played in our experiment. It provided the catalyst, which sped up the reaction. And our elephant toothpaste reaction was exothermic. And exothermic means it generates heat. So if I would have put my hand on the bottle, it would have felt warm because the chemical reaction was giving heat out, giving heat off. So that's why in the picture it says heat out. That's different than endothermic reactions. Endothermic reactions need heat. And so if it were an endothermic reaction and you felt the bottle, it would feel cold because it needs heat. So a quick tip to remember is endo means heat enters. So it needs heat for the chemical reaction, and so it feels cooler. Exothermic is exit. The heat is exiting, so it feels really warm. Heat's being produced during the exothermic reactions. So endothermic, it's going to get cold and it's going to need heat. Exothermic gives off heat and it's going to feel warm. So our elephant toothpaste experiment is an example of an exothermic reaction. If I would have felt that water bottle after mixing together the yeast and the hydrogen peroxide and the dish soap, it would have felt warm. And so that was our exothermic example. An example of an endothermic reaction would be instant ice packs. So in instant ice packs, you squeeze it to activate or break it to activate, and ammonium nitrate mixes with water. And it takes a lot of energy to break up the crystal structure of that ammonium nitrate. And so it needs energy and it absorbs heat and it becomes really cool. And that's why we use it to make instant ice packs, because it's an endothermic reaction. And as it's happening and after it happens, it's going to feel really cold and we can use it as an ice pack. If we injure our wrist or something and need an ice pack and we're out where there's no ice, we carry these instant ice packs. And that endothermic chemical reaction is what lets it feel cold. The last thing I want to talk about is safety. When you're doing chemical experiments, safety is really important. So understanding the right personal protective equipment, so things like if you need safety goggles or if you need to wear gloves to protect your hands, those types of things are really important before doing any chemical experiment. And then I also joked about brushing our teeth with the elephant toothpaste, but scientists never, we never eat our experiments or taste them or put them in our mouths because that wouldn't be safe. That always wouldn't be safe. All right, thank you, and I will see you next time.